The year 2026 has marked a definitive shift in the global balance of power, as quantum technologies move from theoretical physics into the hands of strategic military planners. The integration of quantum mechanics into the kill chain has created a landscape where speed, stealth, and security are being redefined at the atomic level. This transition, often referred to as the second quantum revolution, is fundamentally altering three pillars of modern warfare: secure communications, battlefield sensing, and strategic optimization. The most immediate and high-stakes impact is the collapse of traditional digital camouflage. For decades, military secrets have been protected by mathematical encryption that would take a classical supercomputer billions of years to crack. However, the development of fault-tolerant quantum computers has effectively unlocked the current standards of RSA and ECC encryption. We are now living in the shadow of the harvest now, decrypt later reality, where adversaries are realizing that any data intercepted over the last decade is now transparent. In response, military forces are racing to deploy quantum key distribution (QKD) systems. Unlike traditional codes, QKD uses the fundamental laws of physics, specifically the observer effect, to secure a link. If an enemy attempts to eavesdrop on a quantum-secured communication line, the act of observation itself collapses the quantum state of the photons, instantly alerting the command center and rendering the intercepted data useless. On the physical battlefield, the era of the invisible war is coming to an end. Quantum sensing is making traditional stealth technology, such as the radar-absorbent coatings on F-35s or B-21s, bombers, increasingly obsolete. Quantum radars work by generating pairs of entangled photons. One is kept at the base while the other is beamed toward the target area. Because the photons are entangled, any interaction the scout photon has with the metallic surface is instantly reflected in its twin back at the base. This allows for the detection of low observable aircraft and submarines that currently rely on scattering radio waves to stay hidden. Similarly, quantum gravimeters are allowing forces to see through solid earth and water. By measuring microscopic fluctuations in gravity, these sensors can map out deep underground bunkers or track silent nuclear submarines hiding in thermal layers of the ocean that sonar cannot penetrate. The tactical decision-making process is also being supercharged by quantum classical hybrids. In 2026, the complexity of the modern battlefield, which includes thousands of drones, cyber attacks, satellite feeds, and troop movements, has exceeded the cognitive capacity of human commanders. Quantum optimization algorithms are now used to manage swarm intelligence. During large-scale operations, quantum processors can calculate the most efficient flight paths, fuel consumption, and target priorities for thousands of autonomous drones simultaneously in real time. This allows for a level of synchronized saturation that was previously a logistical impossibility. Furthermore, quantum-accelerated simulations are being used for strategic wargaming, allowing generals to run millions of variations of a conflict scenario in seconds to identify black swan risk before a single soldier sets foot on the ground. Beyond hardware and software, quantum science is revolutionizing the materials of war. By simulating the quantum behavior of electrons, defense laboratories have developed new high-temperature superconductors and ultra-resilient alloys for autonomous hardware. These materials allow for the creation of hypersonic missiles that can withstand the extreme thermal stress of Mach 10 flight without degrading, and batteries with energy densities high enough to power directed energy weapons, lasers, on mobile platforms. The global impact of these technologies is creating a new quantum iron curtain. Nations that master the quantum domain first will possess a first-mover advantage, so significant that it could render traditional nuclear deterrence secondary. If a nation can negate an adversary's stealth, intercept their unbreakable communications, and out-optimize their logistics, the very nature of deterrence changes. As we move deeper into 2026, the military world is learning that the smallest particles in the universe are now dictating the largest movements of global power, creating a future where the silent, invisible calculations of a quantum processor are as decisive as the roar of an engine or the flight of a missile.